Hello everyone, welcome to my channel, The Analyst. Today we'll speak about stepwise regression. We'll look at all the three stepwise regressions, which is forward, backward, and application of both forward and backward. So we'll be constructing three models. Before you all have a look at this video, please have a look at my linear regression video so that you understand things better. Now, moving on to the current video. What is forward stepwise regression? Basically what we do is that we start with a constant, and then from all the variables that we use to construct the model, we pick them up one by one, alright, to check which has the lower AIC. Now a lower AIC indicates that the model will perform better. So forward, you start with a constant, then you pick up one variable, and then you keep on adding variables to check whether the AIC improves. If it does not improve, you stop over there. Second one is backward stepwise regression. In backward, you start with all the variables and then you keep reducing the variables to check if you get a better AIC on reduction of the variables. The time that you do not get a better AIC on reduction, we just stop over there and say that okay, these are the variables that will be used to construct my model. Similarly, in forward and backward, we use both the tactics of adding a variable and removing a variable to check whether you can get the lowest AIC. Now the variables that remain after adding and removing certain other variables is what will be used to construct the model. Now let's move on to our demo. Alright. So as usual, what I do is that I clear up my environment, I set a seed necessary to replicate or reproduce my results. Then over here I'm using the US crime dataset. Right. You see the US crime dataset over here. I will attach the link in the description for you to have a look at. So US crime dataset contains 16 variables. One variable of the 16 is the target, which is crime. We have 47 observations, right? 47 observations, and you have 15 other independent variables. The idea over here is to form a linear model that will be used to predict crime. We'll do so using stepwise regression. Now, let's construct our first model, but before doing that, what we'll do is that, as you see over here, the variable SO, right, it has 1 and zeros, so kind of like categorical variable, alright. So let's remove it out and scale the rest of the data. The idea behind scaling is to bring it about a center. Okay, as you can see, the data really varies for a particular column and we don't need that. So let's scale our data first. We take our crime data. Okay, we read the data, saved it in crime data, so we have crime data object. We have the head over here. Now I take that same crime data, I exclude column 2, which is SO, and column 16. 16 is my target crime. This is what we are trying to predict, so I'll not need to scale this. Now I'll use the function scale and then I'll view the data. Okay, the data has been scaled, all the variables have been scaled. Now we're good. Let's jump into basically checking stepwise regression. Alright, we'll start with backward first. Now we need our data proper, so what we'll do is that we'll add back variable 2 and 16 to our data set and call it scale crime data. Okay, so this is our prepared data set. As you can see, scale crime data contains 47 observations and 16 variables. If you have a look to the right over here, see SO and crime, the ones that we removed earlier, are added back. We use the cbind function for that. Now moving on to construction of our model. So the first thing that we'll do is that we are first going to look at backward elimination. Alright. So backward elimination, like I said earlier, is given that you have 15 variables, excluding the one that basically is your target. You have 15 variables. We'll use all the 15 variables and then we'll eliminate one variable at a time to check whether we are improving our model score, which is by AIC. So the lower the AIC, the better. So that's why I use all the variables, I feed in my data, and then I use the step function to basically remove one variable at a time and check the AIC, and direction is backward because we are doing backward elimination. What we see over here is that the step function, what it does is that first it considers like all the variables, the 15 variables that we have, alright, and we have an AIC of 514. Now what it will try to do is try to remove any of these variables to check whether the AIC can be reduced. So if you see over here, if it removes, this is a minus sign, if it removes the SO variable, then the AIC of the model improves to 512. If it removes LF, again 512.96, but higher than the SO. And the one over here, which basically removing of the inequality. In fact, removing of INEQ increases the AIC, so it's even worse for the model. So what we'll do over here, our goal is to reduce the AIC. The model goes and removes about SO, so that you get the next model at AIC 512. Alright, so that's the first step that it takes. So if you see over here, step 512, and what it did was that it removed SO, which is basically this variable over here. If you see now, our model over here, it has been constructed without using SO. The SO variable has been removed. Now, given that you have these variables, next what it tries to do is that again, it tries to reduce the AIC. Over here, as per it, if it removes the time variable, the AIC of the model will reduce to 511.01. So that is lower than this. So here, right on top, you see the variable that basically on removal that will give you the best AIC for the model will be present right on top. So since 511.01 is lesser than 512, it will go about and remove the time variable. So if you see in the next one, it tries to construct a model without the time variable. Okay, the time variable has been removed, and you get a AIC of 511.01, which is basically this. Now, with these variables, again it will follow the same step. Okay, it will check which variable from these to remove, and based on that, it will check whether the AIC is reduced or not. Now over here it shows that on removing the LF variable, you can achieve an AIC for the model, which is at 509.37, which is again lower than this. So the LF variable over here needs to be removed. Give me a moment, please. Very sorry. Alright, continue. Now, these are our variables that we got, an AIC of 511. Similarly, what it does over here is that it checks on which removal of a variable from these will it get the best AIC. Where were we? Over here. Okay. So as you can see, on removing the NW variable, you can further reduce the AIC of the model to 507.77. So that's the next step. It removes the NW variable, which is over here. As you can see, there's no NW variable and the remaining are kept. And the thing is reduced to 507.77. Similarly, again, the PO2 variable once removed reduces the AIC. So it removes the PO2 variable and so on. So it gives you a 506. Again, removing the POP reduces the AIC of the model. So it removes the POP. Okay, no POP variable over here. Finally, if you look over here, let's just jump to the last step. Okay, so if you see over here, you have an AIC of 503.93 with these variables that are remaining. However, what it says over here is that if you keep these variables and construct the model, you basically receive the best AIC. Okay, removal of any other, so that's why it is none over here, which is 503.93, which remains the same. Removal of any of these other variables like m.f will increase the AIC of the model to 505.16, which is higher than 503. So this is how by removing one variable at a time, the algorithm calculates which combination of variables gives you the best AIC. That is over here by we construct our model only using these variables. Alright, so these are a final set of variables that are important for constructing the model. It also gives you the intercept and the coefficients to construct your linear. So you have a linear model, right? So a linear equation is what you have. Now given that you have the values of m, ed, p01, m.f, you can substitute those in order to predict crime. So you have the coefficients, which is 117 into m plus 201.50 into ed plus 305 into p01 plus 65.83 into mf, which is basically a linear equation, minus 109.73. So you have the coefficients, you have the intercept, you have everything that is used to construct a linear equation used to predict crime. Crime is what we are trying to predict over here. Okay, so this is about backward removal of variables. So you have stepwise regression and basically you're using backward stepwise regression. Now let's have a look at the forward elimination. In forward elimination, as you see, we construct a model first using a constant 1. Okay, then what we do is that we use the step function and a scope. We define the scope over here, which basically includes all our variables. Now we have 15 variables. Why 15? Because that's 16 variables basically includes the target variable, which is crime. We exclude that and then we have 15 variables. So we predict on all the 15 variables and we use a direction of forward. So in forward elimination, what we do is that we add, actually it's not, let's call it addition, okay, because it's not really elimination. First what we do is that we use a constant and then we check what the AIC is. As you can see, the AIC is pretty big. Now over here in the model, if you see, it says addition of which variables gives you the lowest AIC. So when you add P01, it gives you an AIC of 532. Addition of any other variable gives you a higher AIC. And like I said in the start, the AIC, the variable that gives you the lowest AIC is the best. Okay, your model should always have a low AIC. Now, so it adds the P01 and it constructs a model using only the P01 variable. Then it checks for the rest of the variables whether adding any of the other variables will improve the AIC. Again, adding inequality, current AIC is at 532. If you add inequality, the AIC of the model improves to 524, which is lower. So it keeps on doing this until a point that addition of more variables will not improve the model any further. So that means your AIC will not be reduced. Okay, so if you see over here, we have come to the last step, okay, wherein basically the model thinks that addition of any other variable is not going to improve it further. So you have these variables on which it's using to construct the model, and now addition of none gives you 504, and if you add any other variable you get 505.0, which is above 504. Okay, so we stop over here only. So using forward addition, we get these variables that will be used to construct the model. Similarly, here you have your model, which basically gives you a linear equation. You have your variables, you have their coefficients, and you have the intercept that can be used to construct the linear equation. Now we've had a look at forward, we haven't had a look at backward. Now let's have a look at using both forward and backward for stepwise regression. Now we'll have a look at both forward and backward. Here I have my model. I have my model both object. I use step function. I feed that. Scope is basically you have lower and upper which you define. The lower is you start with constant. Upper is that you include every variable possible. And direction you define as both, since we're using both forward and backward. Now here what happens is that we start with backward, so that means the model starts with backward. That means it considers all by default also. Okay, if you do not specify a direction, it starts with backward only. But here we are looking at both forward and backward. Right? So it starts with backward, it considers all the variables, and it calculates an AIC of 514. Next, it checks whether addition or subtraction of any variable is going to improve the AIC. Here it says that the SO variable on removal gives you a better AIC. So then in the next step, what it will do is that it will have an AIC of 512 on removal of the SO variable. So it removes the SO variable, as you can see. Now you have your variables over here without SO, and it got a better AIC. Similarly, it performs, again, it removes time to get a better AIC. It removes LF, NW, PO2, POP. As you can see, it always thinks that in this sense, see, it's saying if you add a PO2 over here, then basically you get an AIC of this thing. But we only have to perform the action that improves the AIC, whether it is backward or forward. Backward elimination or forward addition. So you can see everywhere it is just removing variables, because the model does not think that, you know, addition of any variable is going to improve the AIC. Yeah, finally. Okay, this is the end of it, where it says no, you have this many variables, no more any addition or subtraction will your AIC improve. Okay, so this is where we stop. If we were to add wealth, then the model AIC will be 505.07, which is higher than this, so not a good thing. So this is where we stop. So we have the model will be constructed using only these variables, and over here it basically gives you an equation that you can use. So you have your variables, you have the coefficients, and you have the intercept to construct your linear equation. I hope you've understood stepwise regression, all forward, backward, and backward applied together. Hope you enjoyed the video. Please subscribe and like it. Thank you so much. Bye-bye.